meter per second. So means if you know x, can you get the velocity?
Yes.
So you need to differentiate, right? You need to differentiate x to get the velocity. And then you need to differentiate the velocity to get the acceleration. So class, for you to be able to find the kinematics quantity, what you need to know, all of you should be able to differentiate and integrate. Okay? From position to velocity, velocity to acceleration, you have to differentiate. Or if we give it to you the accelerations, can you get the velocity? You have to integrate the accelerations to get the velocity, integrate the velocity to get the positions. That's the idea, eh? So I want just to make sure that all of you are ready with the differentiations and integrations, okay? For you to be able to find the kinematics quantity, right? Positions to velocity to accelerations. All right, so clear, eh? So this is the two learning outcome, eh? All right. Okay, now let's look at the content of these topics. First, I will give you some overviews of mechanics, okay, and then introductions. What is the rectilinear motions? How to get positions, how to get velocity, and how to get accelerations. Once you are able to find these three kinematics quantity, all of you should be able to determine the motions of particles. Okay, and then of course we provide to all of you sample problem to enhance or to boost your understandings. Right? So that's the ideas. Okay, let's start with the introductions. So what is the meanings of kinematic relationships? So these kinematic relationships are used to help us identify the trajectory of the snowboarder completing a jump. So you look at the figure here, class. Now you look at the figures. Look at the figures here. The snowboarder are trying to complete the jump. Is it in a straight line or in a curved line? It is in a curve, right? So that's involved the curvilinear motions. Or the accelerations during the acrobatic flying. Eh? So these are the example of the kinematic relationship. And then you can also refer to the case of rockets. The motions of large objects like rocket, aeroplane, and cars can often be analyzed as if they were particles. Why? Because we need to know that we can sometimes consider movement of center of mass only by ignoring the rotations. Okay? We can consider it as particles. So I give it to you the simple example class. You have a sport car can travel along a straight road. Can we treat the particle as can we treat the car as a particle class?
Yes.
Yes or no?
Yes.
Yes, right? You can simply have this is the road, or you can simply have like a box here representing the car. So of course you have to include all the forces acting on the cars here. So you can treat the car as a particle. There's no problem with that. Okay, all right. So if the car accelerates at a constant rate, can we determine positions? Can we determine the velocity at some instant? Yes, you can do that. And how to solve this, how to determine these two values. And of course, throughout the lessons, I will explain to all of you. Right? All right. So now let's start with the overviews of mechanics. I believe that you have learned about statics. So mechanic is what? Mechanic is the study of how bodies reacts to the forces acting on them. Okay, so static means I hope you got the idea what is the static now. It's the study of bodies in equilibriums or at rest. It's not moving. What is dynamics? So dynamic is what? It's the study of body in what class? It's the study of body in motions. So it means can be divided into two, right? The kinematics and kinetics. That's why you have the kinematics of particles, kinetics of particles, even for the case of rigid bodies. So what is the kinematics? is concerned with the geometric aspects of motions. It is a time dependent, so that's kinematics. And how to define the kinetics is concerned with the force causing the motions. I give you a very simple example. Okay, let's say this is your phones. Okay, or you imagine that this is the tables in front of you. Then you try to push the table. What happened? Is it the table move? When you try to push? Yes or no?
Yes.
Yes.
Now you are giving forces to the table. So that's kinetics. Giving forces to the tables. So that's what we call as the kinetics. So to make sure that you understand this, let's look at the videos here.
Hello friends, we all know what this line means. Its ups and downs are reflective of the various situations in our life, or rather our life itself. The blood is continuously flowing through our arteries and veins, supplying nutrients to various organs and fighting off invaders. The earth has been spinning since time immemorial, creating what we call day and night. Do you know what all these events have in common? They are in a state of movement or motion. Have you ever imagined what would happen if the aspect of movement was removed from these events? That is, if things stopped moving. The consequences are unimaginable. Even if we are faced with a traumatic event, we are told to leave the past behind and move on. These examples are few of many that serve to prove the phrase movement is life. The different types of motion in all scenarios are studied by physics.
It's always related to physics,
To
right?
understand this, let us take a walk in the park. While in the park, we see a lot of people doing various activities like walking, running, playing, cycling, etc. But what are all these people actually doing? And what do all their activities have in common? Well, they are moving, or they are set away in motion. But what is this motion? We have all heard the phrase time and tide waits for none. The part of the phrase which says waits for none indicates that for us to be regular, we have to do things on time. In other words, we have to move with time. This movement with time is called motion.
Right, class, eh? Movement with time, eh?
We will realize that the phrase is also a comparison of ourselves to time. Thus, for a body to be in motion, it has to be compared to or related to something. Hence, when we see anything moving, we see that it's in motion. And if it's not moving, then we usually say that it's not in motion or stationary. But with
So class clear with the definitions of moving, statics, and dynamics. Any question, class, on that? Are you clear with the moving and not moving? Now, can you
Clear.
differentiate between statics and dynamics? Yes. Okay.
Yeah.
All right. Good. Thank you, Daniel. So now let me give you a bit details. So what is the kinematics and what is the kinetics? Okay. Kinematic is the study of the geometry of motions. So means that all the kinematic quantity like displacement, velocity, acceleration, and time without reference to the cause of motions. Okay. And then kinetics means what? Study of the relation existing between the forces acting on a body, the mass of the body, and the motions of the body. And as I mentioned to you before, kinetic is used to predict the motion caused by the given force. You are trying to push, okay? You are trying to give force or to determine the force required to produce a given motion. That's class the kinetics. So clear the kinematics and kinetics. So particle kinetics includes rectilinear motions and also the curvilinear motions. So rectilinear means what, class? Positions, velocity, and accelerations of a particle as it moves along a straight line. That's rectilinear motions. Then you also have the curvilinear motions. So means what, class? Positions, velocity, and accelerations of particle as it moves along a curved line, either in 3 dimensions. So that's what we call as curvilinear motions. Okay, move along a curved line, curvilinear. Move along a straight line, that's rectilinear motions. To make sure that you understand this, allow me to give to give you some videos to explaining on these two motions.
Observant. Though objects in the park are in motion either directly or indirectly, we notice not all motion of people or objects are the same. So now let's understand the different types of motion involved. In this situation, we can see that the person is jogging on a straight road. This type of motion, which occurs along a straight line, is known as rectilinear motion.
That's rectilinear.
Light in the sun, light bulbs, and stars always travels along a straight line, and hence is the best example of rectilinear motion. Now, if we consider children playing with the ball, we see that when they throw the ball in air, it does not travel along a straight line, but rather takes a curved path. This type of motion is known as curvilinear motion, in which a body travels along a curved path. Can you recognize any other activities in your day-to-day life which involves curvilinear motion? Game of cricket is a good example. When we bat for a six, we notice that the ball follows a curved path as it crosses the boundary. Now that we know what rectilinear and curvilinear motion is, let's look.
Okay, clear class on that. The curvilinear and rectilinear motions. Any questions on that?
No.
Okay, if I ask you what other activities involve the rectilinear or curvilinear motions, can anyone give it to me the examples? Rectilinear, I give you the example. The car move along a straight roads. That's rectilinear motions. Curvilinear, let me give you like a roller coasters. So that's curvilinear. Any other example or any other activity involve these two motions? Can anyone provide some? Yeah.
Bowling.
Jumping what? Again. Okay, you means that jumping from one position to another positions. So that's involve what? When you jump, can you imagine what happened? Is it straight or curve? Or some of you might have yes, is it some of you play netball, basketball? Can you imagine that? The motions, is it in a straight or in a curved line?
Curve.
Okay, other example. Anyone? Try to look at surrounding you. Try to look at is there any example that you can relate with the rectilinear and curvilinear motions? Plus?
Sir,
Yes.
the moving of cable car?
The movings of the cable car. Okay. Is it in the rectilinear or curvilinear motions?
Rectilinear.
Can you imagine that
Oh,
yeah,
going down.
yeah, it might involve the two motions because depends on the weights, right? So
Yeah.
cable might have the tendency to bend. So that's involved the curvilinear motions. Okay. Fishing. Okay, fishing. How to relate fishing with this these two motions? Okay, beside that, what else? So at least class, I just want to mention that you got the idea first. What is rectilinear? What is curvilinear? So after this, when you go outside, okay, or when you go to the bazaar after this, when you see something, yeah, that's rectilinear. That's involved the curvilinear. That's the way class on how to relate what you have learned today. So I hope you got them ideas, eh? Okay, all right. So now class, okay, pendulum, yes, the good example on the curvilinear motions. All right. So now class, let's look at rectilinear motions. Okay, we start with the rectilinear first. how to get positions, how to get velocity, and how to get accelerations of particle moving along a straight line. So first you need to know what is rectilinear motions. As I mentioned to you, particle moving along what class? Along a straight line. That's the example. So let's say start from point 0 to point P. So these positions, you can use any symbol. Some are using the terms of X. If I'm moving in Y directions, you are using the terms of Y. Or you can use S for the scalar. You can use R for the vector components. Okay, so these are what we call as the positions. Okay, particle travel along a straight line defined by the coordinate axis S or X, right? So anyone knows what is the units of position, class? So what is the units of positions? So normally we are using the units of what class for positions? Distance.
Meter.
Meter, right? Positions mean any distance from point A to point B, okay? From point B to point C. Okay, that's the position, that the distance, right? So the unit is meters. And class, if you move, okay, look at the second figures here. If you move from P to P prime, that's we call it as the displacement. So how do you get this delta S? You can just simply S prime minus S, and then it gives you the delta S. That's in scalar form. How to get the delta R? Just simply R prime minus R. That's in the independent form. So normally for the vectors, we are using the symbol of R. For the scalar, okay, you can use S, you can use X, you can use Y, okay, to describe the positions, right? That's the idea. So class, remember position coordinates. So the distance can be positive, can be negative from the fixed origin. Okay, let's say from point 0. If you look at the figures from 0 to, let's say from 0 to point P, now you have the positive distance. What happened from 0 to P prime? Now you have the negative distance from the fixed origin on the line. All right. And the motions of particle is known if the position coordinate for particle is known for every values of time. Means what, class? Okay, let's say I give it to you the example. X equal to, so X equal to 6t squared minus t to the power of 3. If I know the time, if let's say I give it to you time equal to 0, class, can I get X? Yes or no? If time is 0, can I get X?
Yes.
Yes, right? You will get the 0 positions. If time is equal to 2 seconds, can I get the positions? Yes or no?
Yes.
Yes, right? So you got 16. So by the end, let's say if time equal to 6, you got X0. So by the end class, you are able to manage to plot one position graph, okay, with respect to the time. So now class, okay, first we have this graph. Pay attention to the graph, because by having all the 3 graphs for positions, for velocity and acceleration, you're trying to come up with 2 conclusions from that. Okay, now you have one graph based on the formulas here, based on the equation given to you, the position equations. Now class, let's look at how to get the accelerations. Before acceleration, velocity first. So how to get the velocity? So what is the velocity? Is of the rate of change in the positions of the particle. It is a vector. Let's say x equal to 6 squared raised to the power of 3. How do you calculate velocity? How do you calculate velocity? How do you calculate velocity?
Differentiate.
Differentiate.
You differentiate the positions, right? With respect to time, because motion in time, right? So you differentiate the x over dt. So the formula for v is dx over dt. All right. To get the velocity, you differentiate the positions. All right. So means that, can anyone give it to me the answers? If your x equal to 6t squared minus t to the power of 3, what is the values of velocity? Anyone? How to differentiate this? So what is the concept of differentiation for the formulas here? Give you what? Anyone? I hope you still remember on how to differentiate and integrate, class, right? If we give
Yes,
you
sir.
6t squared minus t to the power of 3, velocity equal to what, class? Anyone?
12t minus 2t
12t
squared.
minus
2t squared.
2 or 3?
Oh, sorry. 3t squared.
3t squared. Yes, good. So remember, make sure you know how to differentiate. X equal to 6t squared minus t to the power of 3. So the velocity, of course, equal to 12t minus 3t squared. All right, clear, class, on how to get the velocity. Differentiate the positions. And class, what is the units of velocity? Anyone?
Meter per second.
So meter per
second.
meter. All right, good. Meter per second squared refer to what? Meter per second square. Velocity. Okay, all right, clear. So velocity, the velocity is of the velocity in meter per second. So class, the same concept. If you know x, how to get the velocity, you differentiate the positions and then give you 12t minus 3t squared. So the same concept, class. If time is equal to 0, so you got 0. If time equal to 2 seconds, so you got 12 until, let's say, up to 6 here. So clear? Now you got the velocity. Now let's look at the accelerations components. All right. So what is the acceleration? It is the rate of change in the velocity of the particles. It is a vector quantity, and what class? Again, what is the units of accelerations? So what? Meter per second, meter per second. Yes. So how do you calculate the values of accelerations? If the velocity is equal to 12t minus 3t squared, how do you calculate A? Accelerations. Means what, class? How do you calculate A? You
Velocity.
differentiate the velocity. Differentiate the velocity. Yes, correct. Okay, if you know the velocity, of course you can get A. Differentiate the velocity, give you A. Or the trive derivative of the positions. Okay, or d squared x over dt squared. And it gives you the positions. It gives you the accelerations. All right. So the same concept, class. If v equal to 12t minus 3t squared, anyone can give it to me? What is the formula for A now? If you differentiate the velocity, become what, class? 12 minus
60.
12 minus 60. Yes, correct. Thank you. All right. So once you know V, you should be able to get A. Right? And it gave you 12 minus 60. T0, it give you 12. A equal to 12. T equal to 2, it give you 0. T equal to 4 is equal to negative 12. T equal to 6, it gives you negative 24. Now, class, you can imagine that now you have the tree graph. Okay, let's look at the tree graph. Okay. X, these are the formulas. You differentiate the position, it gives you the velocity. You differentiate the velocity, it gives you the accelerations. Okay, let me ask you, what are x, v, and a at time equal to 2 seconds? If I give you t equal to 2 seconds, can I get x? Can I get the velocity?
Yes.
Can I get a? Yes, right? You should be able to get all the values. And the same thing, if what are x, v, and a if I give you time equal to 4 seconds? Can I get x? Yes or no?
Yes.
Yes, right? So Now you got all the values. Okay. Now what we are going to do here, so okay, back to this. All right. Now class, you look at this tree graph. Okay, look at this tree graph. We are trying to make two conclusion based on this tree graph. It's very important. Like if you do not know this, you cannot solve or you cannot analyze the motions of particle. Okay, look at the first. Now you have the first. Take note on this class. You have the second and you have the third graph here. So let me ask you. When velocity maximum, what happens? When velocity maximum, what happened to the values of A? Okay, let's say 12. This is the maximum values of velocity. Can you imagine what happened to the values of A?
Zero.
A0. So class, this is your first conclusion that you need to know. Because of what class? Let's say we ask you this. Calculate the maximum velocity by given to you A formulas. If you do not know that A equal to 0, you cannot get the maximum velocity. So remember, the first velocity maximum occurs when acceleration is equal to 0. Clear class with the first one? Vmax is 0. Okay, now let's look at the second option here. So how to come up with the second conclusions here? First, you have A max, A0 velocity maximum. If velocity 0, what happened to the x? Or x maximum when what class? When velocity equal to what? X maximum here when velocity equal to
Zero.
velocity equal to 0. Now class, you have these two. Take note on this, it's very important, so unless you cannot determine the motions of particle. So number one is Vmax A0. Number two is X maximums when velocity is 0. So let's say we ask you calculate the maximum elevations, calculate the maximum positions. To get these values, you have to know that velocity must be equal to 0. Clear class with these two summaries here? Vmax A0, Xmax V0. Clear class on that?
Yeah.
I hope you're familiar with this now. All right. A max, B max A0, and then you have one more is what class? Still remember? B maximum A0, X maximum, what value 0 plus again?
V.
Velocity, right? Okay, good. Velocity 0. Okay, good. Now let's continue. Okay, let me go straight to this. Now, class, I hope all of you are able to find the kinematics quantity, positions, velocity, and accelerations. We have done with the first linear outcome. Now, let's look at the second linear outcome, how to calculate the motions of particle. Okay, how to calculate the motions of particle. Go straight to the table here. So we often determine the acceleration from the force applied. So this kinetic will be covered later. So class, just to let you know that there are three classes of motions. A as a functions of time, A as a functions of positions, and A as a functions of velocity. Okay, so can you think of a physical example of when force is a functions of position? Of course, the spring. And when force is a functions of velocity, of course, you can refer to the drag force here, from the aeroplane. All right, let me try to make it in the form of tables here so that you got the ideas. How to relate the acceleration component as a functions of time, as a functions of positions, and as a functions of velocity. Okay, class. How do you get A? You differentiate the velocity. Is it okay with this, class? Are you okay with this? A equal to dv over dt. The first one. A as a functions of time. So how do you calculate A as a functions of time? You differentiate the velocity. Are you okay with this? Number one.
Okay, Doctor.
All right. So now, class, let's say we ask you, can you, based on this formula, can you get the velocity? So what you can do, class, you can try to rearrange so that by the end you got in the form of this. So it means that dv is equal to A as a functions of time dt. Okay, so class, can I integrate both sides? Yes or no? Can I integrate both sides?
Yes.
Yes, because of what, class? Because t and t. Remember, if this is A as a functions of x and this is dt, you cannot integrate. T and t, yes. X and x, yes. V and v, yes. You can integrate. If you have x here and this is dt, class, you cannot integrate. Please remember that. So how to give the limits? Okay, dv, of course, you can start with v naught to v. At, you can start to t naught to t or 0 to t. And then, of course, give you this. So class, just to ask you, if you integrate dv, it give you what, class? If you integrate dv, it give you?
Velocity.
It give you v, yes, correct. Give you v, right? So here we got the ideas. Now let's look at the second. A as a functions of positions. Now class, time is not given to you. What you have to do? Can you try to find one formulas without involving the time? Because you know that A is equal to dv over dt. So here is involved the times. Now, A is given to you as functions of x. Okay, how to get one equation so that there is no time involved, so that you can get the answers? What you have to do, class? So let me explain to you. So class, without involving the times, all of you should be, these are the formulas. V dv equal to A dx. Because x and x you can integrate, v and dv you can integrate. That's why, class, you can integrate both sides. So some of you might asking, sir, do I need to remember this formulas, v dv equal to A dx? No, class. Okay, but if you can remember, yes, there is no problem. But how to get this is come from the basic equations. Let me explain to you. You know that v equal to dx over dt, am I right? And then A equal to what, class? dv over dt. Are you okay with these two basic equation, class?
Yes, Doctor.
Then I try to rearrange this. So I can say that dt equal to dx over v. Now let's substitute dx over v into this A. So what do you get, class? A equal to dv over dx times v. Am I right?
Yes.
Yes.
So by the end, you got v dv equal to A dx. Am I right?
Yes, Doctor.
So it gave you this. So it means that you don't have to remember because it's come from the basic formulas. A equal to dv over dt, v equal to dx over dt. Right? So you substitute dt into the formulas of A and then it gives you these equations. So when you try to, later on, when you try to look at the questions, if time is not given to you, now you know. Then you can use these formulas. V dv equal to A dx. All right? And the same concept, class, if given to you A as a functions of velocity, still, okay, you have to use v dv equal to A dx. V dv equal to A dx. But in this case, of course, you have to bring the x here. So v dv over dx is equal to A. Or you can rearrange into these positions. Dx equal to v dv over A. Because your A as a functions of v, right? So v and dv you can integrate. That's why class you can integrate both sides. So you have to rearrange so that V and V, X and X, T and T, right? That's the idea. So clear class, what happened, or I hope you are very clear on how to solve problem when given to you A as a functions of T, or we might give you A as a functions of X, or A as a functions of velocity. Clear class on these three. What
Clear.
formulas? Again, Nabila, yes or no?
Yes, clear.
Yes, clear. Okay, good. So you have to know, because if given to you A as a functions of X means that you cannot use A equal to dv over dt. You have to find one equation so that the formulas without involving dt. So what is the formulas? V dv equal to A dx. Alright, that's the idea, class. That's the idea. Okay, last before we end our session today, just to give you one sample problems to enhance your understanding. Okay, class. A particle travels along a straight line to the right with a velocity. So I give you velocity equal to 4t minus 3t squared. So velocity as a function of time given to you. Calculate positions, calculate accelerations of the particle when time equal to 4 seconds. Class, given to your velocity, can I get acceleration? Yes or no?
Yes.
How to get the accelerations?
Differentiate velocity.
Differentiate the velocity. Good. You differentiate the velocity. Okay, A equal to dv over dt. So when time is equal to 4 seconds, can I get A?
Yes.
Yes. So now class, you have A, you have the formula for A, 4 minus 60. You have the formula for V. Can I get positions now?
Yes.
How to get positions? Any idea? If given to you velocity,
Integrate the velocity.
you integrate the velocity, right? So some of you might think, okay, how to integrate the velocity? Okay, now let's look at this. V equal to dx over dt. Now your intention is to get the x, right? Am I right? So what you can do, you bring the x here is equal to v dt. Plus, can I integrate both sides? Yes or no?
Yes.
Because of what? Because your v as a function of what? Time, right? So with t and t, yes, you can integrate both sides. Let's say from x naught to x, and then from 0 to t. You integrate dx and give you x. So x minus x naught. Follow this, you can use the terms of x, you can use the term of x. Equal to integrate v. So what is the values of v? 4t. So it give you what? 2t squared minus t to the power of 3, because 3t cubed divided by 3, so it give you 3 to the t to the power of 3. So now class, when you have these formulas, when time is equal to 4 seconds, can I get s? Can I get x plus? Yes or no? Yes, right? So class, any questions up to this? Okay, any question class up to this? So just to make sure that you understand this. So x from x naught to x equal to this. So means that x minus x naught is equal to 2t squared minus 3 to the power of 2. So class, clear up to on how to get the positions and how to get the accelerations. Any question class? Yeah, okay, clear? Clear class on that?
Clear, Doctor.
All right, good. So with that class, I end my sessions today. So any question class before I end my sessions today? So do you have any question class before I end my session today?
No, Doctor.
Clear, all of you?
Clear, Doctor.
So class, by doing that, let's end our sessions today and hope to be able to see all of you again tomorrow, sir. So class, before we end our class, just remember always taking care of your health. Okay, because the weather now is quite a bit hot. So always remember taking care of your health. If you don't understand on certain topics, just let me know. Okay, you can download all the notes from the U Futures. All right, with that, I end my class today. Assalamualaikum. Very good afternoon to all of you. Good evening to all of you. All right. So with that, thank you everyone.
Thank you, Dr.
Thank you, Doctor.
Thank you.
Thank you so much, Doctor.
Thank you. Thank you.
Doctor.
Thank you, Doctor.
Thank you. All right. Yes.